Hello everyone. So in this video, we are going to discuss about an awesome probability numerical. So let us see that how many of you guys are able to solve the problem. In this question, we have 4 people sitting around a circular table. We also have 4 identical boxes containing 4 different colored balls. Each one of them is given a box and he is asked to select one ball from the box. So we have been asked that what is the probability that two persons sitting next to each other do not select the same colored ball. Pause the video and try the question by yourself first and then jump onto the solution. Before talking about the solution of the problem, first we need to understand this statement. Means no two people sitting next to each other choose the same colored ball. What does this mean? So, if you look at the board, we have A, B, C, D sitting around a round table, right? So let's just say A chooses a red ball from the box, right? Can you tell me who are the neighbors of A and who are the neighbors of A? So we can see that the neighbors of A means the person sitting next to A are simply B and D. So if A chooses a red ball, can B and D choose a red ball? The answer is no. Means B and D cannot choose a red ball. Why? Because B and D are sitting just next to A. So B and D, being the neighbors of A, cannot select a red ball, right? No two people sitting next to each other choose the same colored ball, right? It has been given in the question. So this is what the question means, right? Can C choose the red colored ball? Can C choose? The answer is yes, C can choose a red colored ball. Why? Because C is not the neighbor of A. Means C has the freedom to choose any colored ball, right? So even after investing a lot of time and giving a lot of effort, most of you might have not figured out where to even start the problem. So in order to go to the solution, first we need to talk about the two cases. I also explained you earlier that if A chooses a red colored ball, then C can choose a red colored ball or C cannot choose a red colored ball. Means whatever the option A chooses, C can choose the same option or C cannot choose the same option as well, right? The same thing I have done here, right? I have made this in two scenarios. Scenario 1 is A and C go for the same colored ball, and the scenario 2 is A and C go for the different colored balls, right? So let me explain you the scenario 1 with an example, right? Let's just say that A has chosen a red colored ball. So according to scenario 1, C has to choose red ball, right? So if A has chosen a red colored ball, how many options does B and D have now? Can B and D go for red? The answer is no. So the number of options B and D will have is 3, right? So if A chooses a red colored ball, B and D will have 3 options, right? Now let us come here and talk about the probability now, right? So out of 4 balls, in how many number of ways can A select a ball? The answer is 4C1 ways, right? A has selected a ball now. In how many number of ways can C select a ball now? The answer is 1. Why 1? Because A and C have to select same ball, right? Same colored ball. Now, if I talk about B, right? How many options does B have if A has selected a ball already? The answer is 3. I have explained you this. So B has to select one ball from 3 balls, right? The answer is 3C1. The same is going to be with D. Let me explain you this again. So out of 4 balls, A can select a ball in 4C1 ways, right? If A has selected a ball, then C has no option but to select the same ball as A. Means it can select a ball in one way, right? Now, if A has selected a ball, then we have seen that B has 3 options or 3 choices to choose from, right? So B is going to select a ball from 3 balls. Means in how many number of ways can B do that? That is 3C1. The same is going to be with D also, right? If I talk about the total number of ways, what is going to be that? A can select a ball from 4 balls, B can select a ball from 4 balls, C and D can select a ball from 4 balls. So the total number of ways are going to be 4C1 into 4C1 into 4C1 into 4C1, right? Now let us talk about scenario 2, where A and C both choose different colored balls, right? So let me explain you with the example now. Let's just say that A has selected a red colored ball, right? And C has selected a blue colored ball, right? So when you look on the board, you can see that A and C both, listen very carefully, A and C both are the neighbors of B, right? So can B choose red and blue? The answer is no. Means whatever the balls or whatever the color A and C has chosen, B cannot choose the same color. Means how many options does B have now? The answer is 2, right? Why 2? Because A has gone for the red ball and C has gone for the blue ball. Means red and blue are gone. So the only 2 options that B has now, that is 2. And the same is with D. Why? Because D also has C and A as his neighbors, right? So both B and D will have only 2 options now, right? In scenario 2. Now let us come here. Now in how many number of ways can A select a ball? The answer is 4C1, right? One ball is already selected by A, right? C has to select a different ball. Means how many options does C have now? C has 3 options now, right? A has already selected a ball. C has now only 3 options left. So out of 3 options, C has to select a ball. In how many ways C can do that? 3C1 way, right? 2 balls are selected now. A has selected a ball, C has selected a ball, right? Now how many options does B and D have? The answer is 2. So out of those 2 options, B and D has to select one, right? So 2C1 ways in which B can select a ball and 2C1 way in which D can select a ball, right? And what is going to be the total number of ways? That is 4C1 is to 4, right? Same like the above one. So in order to find the solution of our problem, what we need to do is we need to just add these 2 probabilities together. So when we'll add these 2 probabilities together, the answer which we'll get is 21 upon 64. So this is the answer, right? So this is how you can solve this very scary looking problem. And this was regarding the whole thing which I wanted to discuss in this video, and see you guys.